Alright, continuing our discussion of law, sines, and cosines word problems, we're given a different situation where we have two people, two observers, standing on the shore, and it says they're half a mile apart at these two different points. So they've given me 2 points. Perhaps I'll go ahead and just jot those down. So we have 2 points, A and B, and it tells me that they measure the angle to a sailboat at some point C. So they're on the shore, so let's give a nice little shoreline here. And we got some waves out in the water, very beautiful. We have our point C somewhere out here. They're saying there's a sailboat out here that they both can see. And they measure the angle from their position to the sailboat, this point C. So they've already kind of told me there that this is likely to be a triangle. They've given me 3 points. We know it's a triangle. We're doing law, sines, and cosines. But that's kind of my indicators. This is what we're kind of looking at. They said that this right here is a half-mile distance, and that they measured these 2 angles to the sailboat. So angle A gives us 63 degrees. So 63 degrees, we're going to darken that so we can see that clearly. And angle B is 56 degrees. All right, and that's good. We look at that and we go, okay, well, now what does it ask me to do? So it wants me to find the distance from each observer to the sailboat. All right. To deal with this problem, what I want to do is start by making sure I label things kind of correctly. I don't want to be misled about how I word this. So I'm going to say, let's call point A, let's call it Alex, and let's call point B Bob. So Alex and Bob are our 2 observers. And so what that means is this side here will be Alex's distance, and this side will be Bob's distance as we talk through this problem. What I want to do is identify, though, which of these 2 things up here would be the most useful to work with. We've seen some law of cosines problems, but as I look at this one, I kind of have my doubts about law of cosines, because there are 2 circumstances for law of cosines that we can use. Law of cosines has always provided us with help if we have side angle side or side 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 as our 2 setup options. So that means at a bare minimum, to use law of cosines, I must have 2 side lengths to work with. But they're asking us to find 2 side lengths, and they've only given us the 1. That means neither of these is going to work, which means law of cosines is completely out of the picture, at least for the moment. You might go, well, I can't use law of sines either because I don't have the corresponding angle to this half mile. I don't know what angle C is. Please don't forget that if you have 2 angles inside of a triangle, you really do have the 3rd one. So we're going to go real fast and kind of just grab a calculator to save some time. Do 180 minus 63 minus 56. That's 61 degrees there. That 61 degrees would be my other angle C. So maybe I'll write that down here, 61 degrees. And that's great news. We have every angle in our triangle. We have a side length. We can just use law of sines to find our other 2 sides now. So for Alex's length, let's actually call this little a. I know that's a little bit contrary to what we normally do, but to represent Alex's length, and little b to represent Bob's length. That way we know what we're talking about. So Alex's length pairs up with the angle of 56 degrees. So Alex's length pairs up with its opposite angle, and we know then that the half mile, our 0.5, pairs up with the side, or the angle that we just came up with, the 61 degrees. So as I look at this, I can go in and just very easily solve this. I can take the sine of 56 degrees, bring it up to the top of this side of the fraction, just multiplying both sides by sine of 56. And while it's a little messy in our notation here, it does mean that I can easily plug that into a calculator now. So I'm just going to go in. Now on my calculator, I like to go ahead and set up the fraction bar now. You don't have to do it that way, but if it is available to you, you might as well. And we get sine of 61. And a lot of times when I see students work on a problem like this one, I'll see them get this number and they'll think, oh no, I've done something wrong. They'll go to their mode and they'll get worried and they go, oh no, wait, I am in degree mode, so that's fine. But the number is so small, it's so tiny, 0.47. Well, keep in mind we're measuring distances. and they gave us a half mile. They gave us 0.5 as the length of this side over here. There's no reason to suspect that this distance here would be much different. There's no reason for it not to be. In fact, all of our angles in our triangle are very close to each other. An equilateral triangle has all angles of 60 degrees, so we'd expect all three of these sides to be very close in measurement. Now, they did not tell me how to round, but I would caution you not to round this to 0.5. Because if you say this is 0.5, then you're going to say that these two sides of this triangle are actually the same. And they're definitely not. This side A, this Alex's distance, is actually the smallest side of the triangle. It's paired up at the smallest angle, so I like rounding this one to 0.47 miles. That way I know that it's a little bit shorter of a distance, and we're good to go. Now this is a point of problem where people are tempted to kind of just bail out and go, well, I've got an answer, I'm good to go. But that's not the case here, because we also wanted to find this little b to represent Bob's distance. Now that corresponds to the angle 63 degrees. And notice we'll use the same setup we used before with the 0.5 and the sine of 61. Now if you're really familiar with law signs, you'll know that technically speaking, I could use, instead of this pair of measurements, I could use the 0.47 and the 56 degrees if I wanted now. But I prefer to use given information to avoid rounding errors. If I put a 0.47 in for this distance for A, while it is an acceptable answer, it could cause my value for B to be even further off the mark when I go to do my rounding. So I like to use given information as much as possible. So, having said that, we're going to go in and just do the same thing we did before. We'll bring this up, my sine of 63 degrees here, and then all I have to do is go to my calculator and get that value. Now I am going to use a little shortcut here and do second enter on this calculator because it lets me re-input the previous input that we had. And so instead of the 56 there, we have a 63 now, but everything else was the same. And notice here that I do get a value, if I round to one decimal place, of about 0.51 miles. And it should make sense that this one's even closer to our half because 63 and 61 are much closer together than 61 and 56. But those are our two distances. We've found our two measurements. We need both answers in the problem. Just remember that if you're not given a third angle in a triangle, but you have the other two, there's really no reason not to go ahead and find that third angle. And it helped us a lot in this problem.